So today we're going to talk about a concentration unit called molar concentration. And as you can see, the first part of this particular word is mole. So molar simply means pertaining to the mole. It is the same word as like the big teeth you got at the back of your mouth there, a molar. But that's not what we're talking about here. This is concentration that's related to the mole. Now, you guys are all pretty good at writing this stuff out, so you've probably got that written down. So you don't need to write down molar concentration again, because it's already there. But you can write down molarity. Molarity. Now, molarity is just another way to say molar concentration. So if we're doing if I'm working with another chemist and we need a solution and we've got to make it, we would say, okay, what's the molarity of that solution? What do we need its molarity to be? You're going to make some solutions actually tomorrow. Tomorrow we're going to, once we've figured out how to calculate the molar concentration, I'm going to be giving you guys some lab tech jobs where you're going to be making some solutions for me. And you're going to have to do these particular calculations, and you will have to know what molarity I want you to make the solution to be, and then you will continue on and you'll make the solution, all right? So it's going to be kind of a quick little lab. Well, I don't know how long it's going to take. I've never done this with a class, but it should be good. You're going to get instructed on how to make a solution, and then I'm going to, with your group, give you a certain molarity, and then a certain container to make it in, and then you've got to do the calculations in order to figure out how much to put into that container. Yep?
Why is it in liters?
It's just the definition of the particular concentration unit. It's just the way it's defined, all right? We could actually use liters here as well. There's no reason why, if we were dealing with a large volume of solution, we couldn't write this as 12 liters per 100 liters of solution. That would still be a percentage. In this case, it would be 3.2 kilograms per 1 liter, per 100 liters of solution, all right? So there's no reason why we can't use that. So this is variable, but molarity is defined as being how many moles there are in each liter. So we must have units in liters for this particular type of concentration, because that's the definition of it, all right? So we have here the number of moles divided by the number of liters gets us our molar concentration, which is represented by a capital M, and its units can be written as a capital M. It can be written actually as the unit capital M, or it can be written as this combination unit of moles per liter. So the unit can be written in two different ways. You can write it as a capital M, or you can write it as moles per liter, all right? And in the questions, sometimes I give it to you as moles per liter, sometimes I give it to you as capital M. That's the same way it works even in, chemistry-related papers. Sometimes the chemist likes to write it as a capital M, sometimes the chemist writes it as moles per liter, all right? Now, as you can see here, we have an equation that looks a lot like the equations we've already been using, and like I've been trying to convince you, I'm not going to give you the triangles, but if you have the skills to take an equation like this and put it in a triangle, then awesome. That's better for you to learn how to put it into a triangle than for me to just give it to you all the time. What is going to go on the top of this triangle if I'm putting this in a triangle, Shay? The moles. So moles, molarity, and liters. All right? Okay. So now today, at this point, we're going to do a handful of practice problems. We're going to do some where we're just using this equation, and then we're going to do a couple of problems where we have to use this equation and the molar mass equation, because you'll notice we've got moles in it. And as soon as we've got a triangle that has moles in it, we could always use it to put moles into another equation that we have that also has moles. And I can see your little message bubbles now. Here, give me the phone. Give it to me. Thanks. Leave it right there. All right. So we've already written the triangle down. Are you pouting or are you just sitting there like, oh, okay. We've already done the triangle. Let's do some examples. That's simple. We're going to do 5 examples, and then I'm going to let you do some practice problems. You can go ahead and calculate it. It's not too tough. You can probably figure it out. So this one is straightforward. I've given you moles. I've given you liters. All we have to do is put it in the equation and come up with the correct answer. You've got an answer for it? Question, yep.
Do you like equation or?
I don't care. I don't care. I know some teachers are very picky about that. I am not picky about it. I want the unit to be on the end. You've got to have a unit on your answer. If you're comfortable enough knowing where those numbers are coming from, I don't need to see those units. If you were doing really high level physics where you're using an equation that's confusing and you didn't know what the units were going to be at the end, you would then put the units in and you'd do the math with the units and it would tell you what the units are. But we know what the units are going to be here, so I'm not concerned about it. Okay, so determine the molar concentration, which means we're looking for capital M. M equals moles divided by liters, 0.186, and I'm going to put moles in. I just made a big speech about not being, but I'm going to put it in there. Divided by 0.250 liters, and what do we got? Bree, did you get an answer? 744. 0.744, and at this point, either capital M or moles per liter will do. I don't care which. I use moles per liter typically. It tells me a little more information about it than molarity, but it doesn't matter. I don't care which unit you use. Okay, so that means 0.744 molar or 0.744 moles in each liter. And that tells us a little bit about how many moles there are in that particular volume. All right, let's do number 2. So there's a little bit of a trick to this one. What is the trick to this one? What are we going to have to do here first before we can start calculating? And it isn't a big job, but we do have to do something here. What do I have to do? Yep. Yeah, we've got to have the milliliters into liters. Now, there's a couple ways to do this. One way involves using a power of 10 for that milli, but that's almost overcomplicated. So let's deal with that. We'll deal with it right now. So here we've got a volume of 500 milliliters. All right. Now we need to convert that to liters. Does anybody know how many milliliters are in a liter? Does anybody know how many milliliters are in a liter? All right, there are 1,000 milliliters in a liter. All right. Now, if we were to write 1,000 as a power of 10, that would be 10 to the 3. Now, if we were to do this conversion by using the prefix for milli, then this would be equal to 500 times 10 to the minus 3 liters, because that times 10 to the minus 3 is what a milli is, all right? And that's the way the prefix system works. The little prefix has a meaning. Like kilo actually means 1,000, right? And that would be, you'd put it times 10 to the 3. Now, times 10 to the minus 3 means that we can move the decimal place over 3 steps. And that's the way I want you guys to remember how to do this. The way you do something like this is take that decimal, which isn't drawn in, but it is right there at the end. And because it's a negative 3, you need to make the number smaller. 1, 2, 3. All right? So we move that thing 3 steps to the left to make the number smaller. That's what times 10 to the minus 3 is. So I need you to be able to take milliliters, move it over 3, and write that as 0.5, and I'm going to put 2 zeros behind it because I'm thinking those are significant digits. It means we've measured it with a measuring device that measures very accurately to 500 milliliters, all right? Okay, so now we've converted our milliliters to liters. The way I'd like you to do it, you see the milliliters, take that decimal, move it over 3, okay? That's the quick and easy way we're going to do that. So now we're ready to go again. It says determine the molar concentration. M moles divided by liters, 0.564 moles. And we've done the conversion, 0.500 liters. And the reason I kept the digits is so we can have, again, 3 non-zero digits when we divide. We got a number? Yeah, what do you got, Isaac? 1.13. 1.13 moles per liter. Again, if you put capital M, that would be awesome. Okay? So sometimes we have to convert our milliliters to liters. Yeah, I have no idea where everyone is. We've got various devices going ahead. John, are you ready to go? Number 3. Determine the molar concentration of a solution that contains 1.68 grams of copper sulfate, that's copper sulfate there, in enough water to make 150 milliliters of solution. So in this question, you'll notice that there's something missing. But notice also at the beginning, it says determine the molar concentration. Once it asks that, as soon as the question asks determine the molar concentration, what I would suggest is write down your equation for calculating the molar concentration. Moles per liter. Moles per liter. And now let's go hunting for those values. Is there something in that question that I can already put in to this equation fairly easily? What is there that I can see quite easily? Conrad? You can put 150 milliliters on the bottom. I can put 150 milliliters on the bottom, but what unit must it be in? So I'm going to move the decimal. You don't have to show me that step. What would this number be after I move the decimal? Yeah, good job. 1.5, and you probably can keep the 0. It's safe to keep the 0. 0.15 liters. All right, excellent. What's the other number we need? We need moles, right? But I have grams. How do I turn grams to moles? I need a molar mass, and I need my other triangle, right? Remember, to go from grams to moles, I need molar mass is equal to, what was that unit? Grams per mole. Grams per mole. I want moles. So if I make my triangle, grams, moles, molar mass, I want moles, right? So grams over molar mass. So I've got to do a little work in order to get this one. I've got to get my periodic table out. I've got to get some molar masses, and then I'll be able to finish the question. So I'm going to go way down to the bottom here out of the way. CuSO4, 16 times 4, 31. Sulfur 31. Felicia, you haven't even found 32.1. 32.1, and sorry? 63.5, and that's 1, and that's 1. 159.6? 159.6 grams per mole. We've got our molar mass. We know the grams. 1.68 grams divided by 159.6 grams per mole, and that's going to get me moles. Now, don't clear your calculator when you get that answer. Sometimes we do that too quickly with, with calculations. We press clear. Actually, we don't even just press clear once. You press it again. Then clear, clear, clear. Don't do that. Just relax. Sometimes the number is useful. What do we have as moles here? 0.1, sorry? 0.5? Do we have supporters on that? You like it? Don't clear your calculator, because that number now goes into that spot, right? That moles is how many moles are in that solution. 0.0105 moles. So like I said, if you don't clear your calculator, all you got to do is press divided by 0.15 equals, and it saves you time, right? If you clear it, you got to put it back in, all that type of stuff, right? And Amy's not participating at all today. No, she just, she is. That's what that is. Conrad, what do you got?
I got
0.072. 702 moles per liter. Supporters on that? Would I get? Okay. All right. So you'll notice there, we were given grams. We needed our good old molar mass equation to figure out the moles, and then we could put it in. And I'm just going to look ahead. Oh, yeah, I've only got 2 more examples. We're good. Number 4. So here you'll notice that we've got all kinds of information. We've got a capital M, a molarity. We're wanting a volume. We've got a mass. So we've got all kinds of information, and we're going to need both of our equations. It doesn't hurt to write them both out. Molarity is moles per liter, and molar mass is grams per mole. What are we trying to find? Which of our letters are we trying to find as our final answer in this question? Which of the letters are we trying to find? Yep, Bethany?
L.
L. We ultimately want to get L. We have the molarity, we have the M, which means we need the moles again, right? We've got a mass, there's our grams. We can always get the molar mass, and there it is in the molar mass. So again, we're going to start over here. From our molar mass, get moles, and then rearrange that molarity one to get liters. Again, build your triangles if you're users of the triangles. I need sodium hydroxide. Does somebody have a formula for sodium hydroxide? Yeah, NaOH. It's 1 and 1. Remember, hydroxide's on the back. It's 1 and 1. NaOH 1, 16, 23, and that is a nice one. That's 40. We do these calculations in 3U, except we use conversion factors. We string them all together. We're done in one shot. It was about exactly where you lost interest. Yes, yeah. So, but we use conversion factors. We just slap them all together, which is quick and a different way of doing it, but it's not a problem. So we are solving for, what is my equation to solve for moles? What's the equation going to be? Yep, Bree? Yeah, grams over molar mass. Good. 5.5 grams, and I'm going to be quick here. 5.5 over 40. Yep. 0.137. Did you put a 5 on the end of that? That's okay. It's okay. We've got an extra digit there. Actually, we only need 2 in the end, but that's okay. And that is moles. So that's going to come up into here. What will my equation be for liters? Again, I'm not going to build a triangle for you this time. You can build it if you'd like, however you want to do that. What is my liters going to be, John? Yeah, moles over molarity. I know the moles from over there. 1375 moles. And again, if you don't clear the calculator, you'll use that number, 1.50. And you can put the capital M. There's nothing wrong with it. And we will get a number of liters. And it's going to be a small number. That's okay. Where do you get there, Shay? You're looking at a number, you're questioning, you're wondering. 0, and then I couldn't hear anything. 917. 917 liters. Now, this question doesn't ask it, but what if I wanted you to turn that back into milliliters? What do I have to do to turn it back? What do I have to do? Amy, what do I have to do? Yeah, 3 to the right. I'm just moving it the other way this time. 1, 2, 3, 91.7 milliliters. And that's sometimes useful because I think we can probably, well, we can imagine milliliters versus liters either way, right? Like we know that there's a 2-liter pop bottle, right, the big one. And then they've got the 1-liter pop bottle. There's those medium guys. And then a pop can is, how much, you know how much is in a pop can? What's that? Oh, those are those big guys. I think it's $3.55 for just a regular pop can, around $3.50. So again, we can imagine milliliters, but we can imagine liters as well. The tricky thing is to imagine what 0.091 liters is, right? That's hard to imagine, but we can easily imagine 91 milliliters. That's easier to get in our heads. Okay, one more problem. Now this question is actually very practical. It is what we will be looking at tomorrow. So tomorrow we're going to go over the steps involved in actually making a solution, and then we will go about and do that. And this is the type of question that that I would go through if I was making a solution for you guys. Let's say we were doing a single displacement reaction or something, and we needed some, you know, some solution of copper 2 sulfate or something. I would have to sit down, figure out what mass I would dissolve in order to make my desired concentration. All right, and that's what this question is asking. How much of this stuff would we need in order to make that particular concentration? Notice it's asking what mass. As soon as we're dealing with a mass, whether they give it to us or they're asking it for us, we need our molar mass equation. I wanted that to be black, so I'm going to make a switch right now. Molar mass is equal to grams over moles. So in the end, I'm looking for that grams. And because we're dealing with solutions and liters, I'm going to be using my molarity equation, which is moles per liter. All right? Again, just like on the last test that we did, I will give you that basic equation. You'll have to build whatever triangles you need in order to do it, or maybe you're getting good at rearranging it. That'd be awesome. I have liters, and I have the concentration in moles per liter. Now that moles per liter, that is the same as that molarity. So that number is in that spot, okay? So what am I solving for first? What am I looking for in this first equation? Yep, moles. So I'm going to rearrange here. Oh, that's, what is the equation for moles? I don't know if we've done that one yet on this one. What's the equation? Molarity times liters as it goes up there, or you can like cover it up on the top and you'd have it like that. Molarity times liters, 0.335 moles per liter times, and it is in liters, we don't need to convert it, 1.5. Did I take your calculator away too? Yeah. Here, let me give it back. I feel so bad now. You couldn't participate. It's just not fair. It's fine. You can have it back. It's all right. I've had my fun. What do we have here for a number? Yep. That's okay. Go ahead, Conrad. Go ahead. 0.5. No, it's okay. I said Isaac at the very last second. 0.0. Now I don't even remember what you said. 5025. Scribble, scribble, scribble. 5025, and that is moles. Moles. We're wanting to get grams. That's going to go up top there, or use whatever triangle you use. Grams is equal to the molar mass times moles, and I didn't stop to do the molar mass. Has anybody done that as we were waiting? What was that? 36.5? 36.5 grams per mole. I'm not going to write it in this time. Times 0.5025 moles. And how much of this stuff are we going to have to weigh out? What do you got, Shay?
18.3.
So 18.3, stopping there because there's our 3 digits there. There's 3 digits there. That's good enough. 18.3 grams of HCl. And because Jess is going to be watching this, this is where we got that mass, 35.5 plus 1, 36.5 grams per mole. Okay. So, a new equation for solutions when we're dealing with milliliters. Molarity is equal to the moles per liter. We still have to deal with our grams because sometimes we have to make the solutions, and that's our molar mass equation. So we've just added simply a new equation for getting moles when we're dealing with substances that are dissolved in water. All right? Any questions or concerns? There's some homework. Now, essentially underneath there it says the worksheet. And you know what? You don't have to write this down because you know what I did on the worksheet on the Google Classroom? I cut and pasted those questions out of the book and put them right on the worksheet. So if you don't have your book nearby, those questions are right on the practice sheet at the bottom. All right, so you can just go to the worksheet to practice. Okay? All right, and you've got a good amount of time here. It's looking like about 40 minutes, so you can work away. And I'm going to stop the recording and get it saved.